Hi there. In this video we're going to look at finding the volume of prisms. So just a quick reminder, a prism is a shape, a 3D shape, and it's a polygon that has been stretched to make it 3D. So you start with a polygon and then you stretch it in three-dimensional space, and that makes it 3D. So that's what a prism is. Now to find the area of the volume of a prism, it's very simple and it's the same method every single time for a prism. You find the area of the polygon that you started with, and then you times it by the length of the polygon. So volume is equal to area times by length. Or a L. Now obviously this requires you to be able to find the area of the polygon shape if you're not given it, but we'll look at a few examples in a second where we do just that. Okay, so on to our first examples here. So here we have this pentagonal prism, and very handily they've told us the area of this front face. So again, this is the face that we've stretched to make the prism, so that's the area we're after. And remember, volume is just the area times by the length. Now the area of this front face is 12 centimeters squared. That's 12, and the length is 5. So I do 12 times 5, that gives me 60. And now the units of volume are centimeters cubed. Now you can remember that in a couple of ways. The cubed, well, cubes are three-dimensional, so if you're talking about volume, it's a centimeters cubed. The other way you can think about it is, well, we've done centimeters squared and we've times it by centimeters. Now if it was x squared times by x, that would give you x cubed. It's exactly the same for units. Centimeters squared times by centimeters is going to give you something with units centimeters cubed. Okay, so on to our second example. Now this is a special type of prism, and this is a cuboid. And now you might not think of cuboids as prisms because they've got their own name, but it's a rectangle that's been stretched to make it 3D. So it is a prism, and we can work it out in exactly the same way, and it's going to turn out that the way you would probably ordinarily work out a cuboid falls out from using this method. So remember, the volume is the area times by the length. Now with this one, any of the faces would work to find the area of, because if we look at this face, we can think of stretching that out backwards. If we look at this face, we can think of stretching that out to the side. If we look at this top face, we can think of stretching it down. But we'll work at the front face. So the first thing we need to do is find the area of this front rectangle. Now the area of this front rectangle, well, the area of a rectangle is length times width, which in this case is 4 times 6, which is 24 centimeters squared. So then our volume we can work out as 24 is the area times by 12, which gives me 288, sorry, that should be meters, meters cubed. Now let's just have a bit of a think about what we've done. To get this 24, we've done the length times by the width, so the 4 times by the 6th, and then we've times the answer by the length. So to arrive at this 288, we've done 4 times 6 times 12, which is what you might ordinarily do for a cuboid, but thinking of it as a prism still works. Okay, so on to our third example. Now this example's a little bit trickier for a couple of reasons. The first thing we need to notice is that it's oriented differently to the other shapes we've looked at so far. So remember, the volume of a prism is the face that we've stretched back, the cross-sectional area. If you chop this at any point, you'll get this same area, as long as it's parallel to the front face. So what we need to do is we need to be really careful about exactly which face we find the area of, and we need to be really just clear on which face has been stretched to make this shape. And now in this case, it's actually this triangle that has been stretched to make the triangular prism. So that triangle is the one that we need to find the area of. Okay, so let's have a look at finding the area of this triangle. Now this is a special kind of triangle. It's a right angle triangle. So sometimes in these 3D shapes problems, what it's worth doing is drawing out one of the faces again, just to help us find the area. And that's exactly what we're going to do. So it's a right angle triangle. So I'm going to draw myself out a right angle triangle. Now here, this side is 3 centimeters, and that's one of the sides touching the right angle. So I'll draw that on. Now this length across the bottom is the other of the shorter sides. So that's 4 centimeters. And the hypotenuse, the longest side, is 5 centimeters. Now this allows us to find the area really, really easily. Now the other thing they've done to try and throw us off is they've given us the length of this hypotenuse. They've given us the length 5 centimeters. And now, if you remember, for the area of a triangle, it's the length of the base times by the perpendicular height, and then halved. So what we need to do, what we need to be careful of, is we can ignore that 5. We don't need that for this part of the question. So the area of this triangle is a half times by the base times by the perpendicular height, which is a half times by the 4 times by the 3. Now a half of 4 is 2 times by 3 is 6. So the area of that triangle is 6 centimeters squared. And then we're not quite finished there because we need the volume, but we've got the area now. We know that the length is 6, so we can work out the volume. So the volume is equal to the area of the triangle, 6, times by the length of the prism in the direction it's been stretched, which is this 6 centimeters here, which is equal to 36 centimeters cubed. So that one's ever so slightly trickier, but as long as you know how to find the area of a triangle and you're really careful about which face you're finding the area of to start with, not too tricky. Okay, so on to example number 4 here. So this time it's oriented the same as a few of the other ones we've done. So it's this trapezium that we need to find the area of. That's the shape that's been stretched into a prism. So what we need to do for this is we need to remember how to find the area of a trapezium. Now they've done something else to try and throw you off here, and they've given you some of your lengths in centimetres, and they've given you some of your lengths in metres. Now, a really common mistake people make is to either not convert these and then do the maths first, which is just going to be a mess because they're all going to be in different units, or it's to try and not convert them at the start, get an answer and then try and convert it at the end, which again is going to be really, really tricky. It is possible, but you don't want to be doing that because you're more likely to make mistakes. So some questions might specify what units it wants the answer in. If it wanted it in meters cubed, I'd turn all of my lengths into meters first. If it wanted it in centimeters cubed, I'd turn them all into centimeters first. I think the numbers are going to be slightly nicer if we do it as meters though. So we're going to convert to meters first. So convert to meters. So 80 centimeters, well, we divide that by 100, and that gives us 0.8 meters. And 20 centimeters, we divide that by 100, gives us 0.2 meters. So this is going to make it slightly easier. So the first thing we need to work out is find this area. Now remember, the area of a trapezium, it's the average width of the trapezium. To find the average, to find the mean, we add these two things together and half it. So it's going to be a half of 0.8 plus 1. That's going to give me the average width. And then I'm going to times that by the height 0.2. Now 0.8 plus 1 is 1.8. Half that, you get 0.9 times 0.2. Well, 9 times 2 is 18. But we've not got 9 times 2. We've got 0.9 times 0.2. So we're going to need to move it 2 decimal places across. We need to divide by 100 because we've divided by 10 and by 10. Altogether that's 100. So the area of this is 0.18 meters squared. Okay, so then we need to times that by the length 1.2. So the volume is 0.18 times by 1.2, which gives us now, we can work out 18 times 12. So 18 times 12, well, 2 times 18 is 36, and 10 times 18 is 180. So let's add those together, 216. Now again, we can use a similar trick here. We've got 2 digits after the decimal place here, so that's a division by 100, and we've got 1 digit after the decimal place here, so that's a division by 10. So if we do 216 and divide that by 10 and then by 100, that will give us 0.216. A slightly simpler way to remember that, not quite as rigorous, but it certainly works generally, is we've got 2 numbers after the decimal point here, 1 number after the decimal point here. So altogether, we've got 3 numbers after the decimal point. So in our answer, we should have 3 numbers after the decimal point, which we do. So our final answer is 0.216 meters cubed. Lovely.